Alright class, so this is a quick tutorial to show you again how to bring some data into Grass and reproject it, okay? So as I showed you in class, I downloaded the SRTM data from earthexplorer.usgs.gov. I downloaded these two SRTM tiles. If you recall, one of them covers sort of the west edge of San Diego and the other one covers sort of east edge of San Diego. I downloaded them to my hard drive. They're about 26 megabytes or so each, using the Earth Explorer interface. And these geotips we could open up directly in QGIS and view them just to make sure that they're okay. So once you've downloaded them to your hard drive and you've sort of looked at them really quickly in QGIS and sort of figured out what projection format they're in, now we can go about doing the same thing by bringing them into Grass, okay? So we happen to know that these are in latitude and longitude by default with the datum of WGS84, all right? So with that information in my sort of arsenal, what I'm going to do is start Grass, and we're going to make a new location to bring these files into. And if you remember with Grass, basically you have to know what the projection is first because you set up the location with that projection information, and then you put all your data with that projection and only that projection in that location. So there are a couple of ways we could do this. We could set up a new blank location with the projection information and then import these things into there. But the easiest way to actually do this is to have Grass read the projection information off of one of these files, so it will automatically set it up for you, okay? So we start Grass up, we get our splash screen here, and we go to where it says select Grass location. We click new, and over here we give it a descriptive name. I'm going to call mine lat long WGS 84. That tells me it's latitude longitude WGS 84. That's just the name. It's useful if the name reflects the actual projection. So we click next. We get a few options here. If we knew our code for the CRS, we could actually put that in right here. But since we don't know the code, we'll just select the next one, which says read projection and datum terms from a georeferenced data file. So that's okay. We click next, and then we click browse on the next window. And we go to where we downloaded our two SRTM files. We just pick one of them. Yeah, let's just pick the first one here. It's loaded in there. We click next, and here it is, showing us that it's read in the projection information. Everything that we thought it was is correct, lat long, WGS 84. So we click finish. It's going to ask us if we want to import that file into our new created location. That's a convenience for us, so we'll click yes. It'll do it in the background, and it'll pop up and say everything was good. We set the default region and everything from that map. So we click OK. And here we have this next one that says, do we want to create a new map set? We could at this moment, but we don't have to. In this case, I'm just going to hit cancel because all I want to do is actually now go into permanent so we can import the second of the two SRTMs. We do that, and the Grass interface pops up, and we can load in our new raster file. We see it's already here, the first SRTM 117. Click OK. There it is, right? Now, it's important to note that by default, when we imported this file, Grass set the region extent, the boundaries of the window, to exactly match this map. So if we tried to import the other map, what it would do is import the map, but it would be outside the region, and if we tried to combine them or to do anything else, that would give us some problems. So we just need to know that that's the case. So if we kind of right-click on this first file that we have in here, we go down to metadata, we can actually see its extents of 33.5 north, 3359.59559.5 north, right? Resolution is 1 arc second, like it said. So these are the degrees and minutes and seconds, right? If we go up to settings up here and we go to region, display region, we'll see that those boundaries that Grass is using exactly match the boundaries of that map. So that's just something to keep in mind for a second. We're going to have to adjust that here in a little bit. But first things first, we're going to import our second SRTM. So So we're going to go to File, Import Raster Data, Common Formats Import, r.in.gdal. That's the most common thing we're going to use to import raster data. Brings up this window, and essentially all we need to do is click this Browse button here and go again to where we have our data downloaded. Pick the second one, 118 in this case. Click Open, and then it shows up down here. If we wanted to change the name upon import, when it brings it into the grass location, you could do that here, putting your cursor in there and changing it. But for me, that's fine at the moment. Everything else is fine. There's several options that if you have some advanced needs, you can actually change them, but we'll just leave the defaults fine for now. We'll click Import, and there we go. Everything is imported. So a sort of shifted focus to that one. If we pull up our zoom out tool, we can sort of zoom out and see that we actually have the two files in there side by side. Our layers show them over here, 17 and 18, right? So what we need to do now is sort of update the region settings for this, just so that if we ever choose to do any work in here, that it actually draws the region around both of those two files instead of just around the first one, okay? So I'll just show you again, region, display region settings. They're exactly the same as they were before, meaning it's just this map that it's zoomed into. In order to change them, there's a couple of ways we can do it, but an easy way to do this is just go back to Settings Region and then Set Region, g.region, and it brings up this display over here. And one of the things that we can do is to set the region exactly to match a couple of maps, right? So we can bring in our first one and our second one. You can see actually it's in there. They're separated by this comma right here. So we have the 18 and the 17. So what this is going to tell Grass is set the region to exactly match the boundaries of both of these two maps combined, and also to set the resolution of the raster grid to match both of these maps, right? 1 arcsecond. The other thing we're going to do, since we're in permanent, we'll just click this box that says Save as Default Region. And what that means is that every time we go into Grass now, that the default region is going to be set to match the extent of these two files. So that's pretty cool. We definitely want to do that to save ourselves some hassle down the line. So now we're going to click Run, and it will do it real quick. And we can close that. We go back to Settings Region, Display Region, and now we can see that it's actually changed the east and west boundaries a little bit here. So before it was 117 to 115.5958. Now it's actually 118 to 115.5959. All right, so that's cool. We've saved ourselves some trouble. One last thing before we think about reprojecting these out of the latitude, longitude into a UTM. A very convenient way to sort of help us do that is to make a bounding box of the current region so that we can bring that over first and set up our new location to match exactly the extent that we want it to. So it's really simple. You go to the vector format, vector file, and you go down to, you see this generate area for current region. Just click it, and you call this, I'm just going to call it bounding box. You click Run, and boom, it makes it in the background. So that's basically what we have here. If we look at our layers, we have that bounding box here, and below it we have our two SRTMs. So we're ready to reproject, and remember with Grass, you don't push the files out of one location into another. You set up the new location and then you pull the files into it. So the easiest way to do that is to actually just quit Grass and restart. Quit Grass, no need to save any settings files, and we restart Grass over here. So we want to get back to this basic splash screen here, okay? So what you want to do is to make a new location again, so we get back to the same place here. In this case, since we're going to make a UTM, I'm actually going to call it UTM. I'm going to call it Z11 North, Zone 11 North, because that's what San Diego is. and then WGS84. Again, I can give it any name I want here, but I'm going to give it a descriptive name so that I can remember what it is just by looking at it. Click Next. So in this case, we don't have a already georeference file to read from, so we're actually going to have to tell it the information about the projection system that we want. So we'll click this one that says Select Coordinate System Parameters from a list. Click Next. And we could scroll through this really long list of projection systems, but an easy way to do this is we've got a search window here. Just put in UTM, hit enter, and it'll search through that and say, oh, here, that's the one you wanted, UTM. That's the projection type. And for UTM, it's going to ask you to tell you the zone. So we'll tell it 11. And it's in the northern hemisphere, so we'll leave that alone. We click Next. And now it wants to know about the datum and ellipsoid, right? I'm going to use NAD83. That's the common one for North America. So I'm just going to search for that. It's the first one in this list. These are sort of specialty ones down here. So we'll just click NAD83. And click Next. This is all okay for the moment because we're not in Florida, Maryland, or Tennessee. Click OK. And there we go. It's just telling us the details about all of that. We hit Finish. And we actually don't want to set the default region extents at the moment because we're going to use our bounding box to actually do that for us automatically. So we'll just click No at this moment. And we're not going to make a new map set at this particular moment because all we need is permanent. All right, so that's actually over here. For some reason when I expanded it, it's over here, permanent. And make sure that's selected and then start grass session. So there we go. Grass starts up, and in this particular case, we actually have no data whatsoever in grass. So it's totally blank. And as a matter of fact, if we were to show the current default region, display region, you'll see that it's actually set to be 1 pixel, that's 1 meter, and way down in the bottom left corner of the entire zone 11 of the UTM projection that we're looking at, right? So that's not good. Obviously, if we tried to import a raster map at this point that's up in San Diego, because we have just this one little pixel down in the bottom corner, it's actually not going to show up. So it will try to reproject it, but it will be blank. You will be frustrated, okay? To get around that, what we're going to do is actually reproject the vector map first that we made of our bounding box, of our region, in our other map set, and we're going to use that to sort of tell grass the boundaries, just a sort of quick shortcut to do this. So we're going to go to Vector, Develop Vector Map, and we're going to go down to where it says Reproject Vector Map from different grass locations. So we check that. This little box here shows us a couple of things. We have to tell it which location we want to reproject from. So we're going to go to our lat long. We have to pick the map set. In this case, there's only one, permanent. And then we have a list, and we have only one vector in there, so we just have bounding box. So this is all good. So that's our source, right, the first tab. Target is the next tab. And what we want to do is just give it a name, and we'll just give it the same exact name, bounding box. You can give it any name you want here because it's actually going to make a brand new copy of this file. There are some options over here, but we don't need to do any of that stuff. We're just going to hit Run. And there we go. It's done it. We can actually close this little dialog here. You'll notice nothing has changed over here. That's because, remember, we're zoomed into the bottom left corner of the entire Zone 11 of the UTM projection system. But we can actually right-click on the bounding box layer that shows up in our layer window now. And we can do Zoom to Selected Map, and there we go. We see it right here. So that's really cool. That helps us a lot. But what we need to do now is use this to tell grass to actually update the region to match this bounding box. So I'm going to go to Settings, Region, Set Region, and we're actually going to go down to, let's see, Existing, and Set Region to Match Vector Map. Okay, so that's this one here. We'll pick the bounding box right here, and we can set the resolution as well. So this is a vector, it has no native resolution, so we need to tell it what the grid resolution for any raster maps we're going to bring in will be. So to do that, we click on the resolution tab over here, And we go to the one that says 2D grid resolution, north, south, and east, west. Since the grid cells are square, that's really convenient for us. And we know it's 30. We know that the SRTMs are 30, so we're just going to tap in 30 there. So we have this entered here, and we have our vector entered over there. Now when we hit run, it's going to set that region to be exactly the area that we need for our new map. So we can go display region, and we see actually it's got these bounding blocks now in UTM. These are meters, right, from the datum point, and the north and east-west resolution is about 30. So it may show up as sort of slightly weird, but that's okay. It's pretty close to what we wanted. Oh, and one thing I actually forgot was that I should have clicked this Save as Default Region again, just to save us the hassle of having to reset the region every time we start up graphs. So I'm just going to rerun this, and now that's going to be saved in perpetuity. Okay, so we're cool now. We have our region and our projection and our new location set up. We can bring those other two maps directly over. Go to Raster, develop Raster map. I'm going to go down to Reproject Raster map from different grass location. Okay, so it looks very similar to the vector one. We're going to choose our location, lat long location we made earlier, choose the permanent map set, and now we can see our two exact SRTMs. So there we go. We're going to select the 117. I'm actually going to copy this so that I can go to the target, and I can actually paste the name in there so I can keep the name the same. In this particular case, I'm going to choose a different interpolation method. For smooth data like elevations, we want to pick a appropriate interpolation because it's actually going to warp the lat long projection into the UTM location. It's going to need to do this in an intelligent way. At the moment, I'm just going to tell you Lanxos is an efficient one, and of course we're going to tell it we want it to be 30 meters resolution, right? So we're all good here. We hit run, and it's going to bring that map in. It's going to chug through the interpolation and reprojection algorithm. It's actually quite mathematically intensive, so the computer takes a little while depending on the size of your raster file. And here we go. So there we go. We have our first one. We see it over here. We just go back to our source tab over here in our r.proj window, and we can actually select the second one, 118, and do the same thing I did before, which is just copy, go to target, and delete that one, and then paste. So it says 118. So now I'm going to do that. I'm going to leave the other settings the same, Lanxos with 30 meter resolution. I'm going to hit run. It's going to chug through it. It'll take just a little bit of time. And there we go. We have our two maps brought in. They're side by side over here. But as you can see, they sort of don't look seamless because they're two separate tiles. They have their two separate color maps. So one thing that we could do is actually patch these two maps together so we don't have to deal with two files and two layers every time we want to display all of this information. And that's actually really easy in Grass. We go up to the raster menu, and we go down to, where is it here? Overlay rasters, and then we find the one that says patch raster maps. That's exactly what we want to do. So r.patch. Click it, and it comes up. By default, it's actually, since I have one of the layers selected, it's like already by default selected it here. So all I have to do is select the second one. And you can see, as before, it's put a sort of comma between the two, the 118 and the 117. That says read in these two maps and then combine them into a second one over here. So I'll just call this one SD SRTM patched, right? It's just, again, a convenient name. Again, and there's going to be no spaces in any of these map names and actually no dashes. I'm using underscores right here. And I don't need to do anything else. That's everything else in this particular module is fine. I hit run, and again it's sort of chugging through. And when it's done, it's going to load in the sort of patched map right on top. Alright, so anyway, so there you have it. Your maps are now reprojected, and everything is in a linear coordinate reference system, so you can do all kinds of fun math a little bit later on.